Hey kids, welcome to week 2 of science. I have my partner Holly with me. High fives. Psh. Right now you might hear some thunder outside because we have quite the rainstorm. What is thunder, babe? What causes that? Thunder and lightning.
There's ice in the sky that goes into, it makes, and then it goes, and then
friction cause the electrons to get excited and poof. Have we studied about electrons recently?
It goes into water.
Well, the water freezes, and then as it gets higher and higher, and all of that ice and those water droplets rub against each other, they cause friction and excite the electrons, and that's what causes lightning, is when it jumps. So, have we studied electrons recently? Yeah, last week. You remember we're studying chemistry. What is chemistry?
It's chemistry.
Do you remember our song? What is chemistry? Chemistry is the study of matter and how it changes. And we made up a fun little game. What particles make up an atom? And we said protons, and we jump forward and we say positive, heavy, and we squat down. Then we say neutrons, neutral, heavy. And then we would jump backwards and say electrons, negative, light, right? So we studied the parts of an atom. This week, we're studying the fact that all matter is made up of atoms. Then why are there so many different things if we're all just made up of protons and neutrons and electrons? Because depending on how they're organized, how many protons are in the atom, how many electrons, and the weight of the atom affects what that atom does, essentially, right? So an atom has protons and neutrons in the nucleus. If any of you got to work on it this week, we tried doing the craft project of using beads, and we made a little nucleus of protons and neutrons, and then we didn't get to add our electrons on the outside. This is called the nucleus, where all the protons and neutrons are. And then the outer part is called the electron cloud. Most of the mass of an atom is in the protons and neutrons since they're heavy, right? The electrons are very small, but they take up the most space. The electron cloud is where they take up a lot of space. The number of protons will always equal the number of electrons. And what's amazing is scientists throughout the years, as they've discovered the makeup of various things, they found that they could break them down into elements. Certain things that are made of the same elements that have the same properties in their atoms. Yep, let's pull it out on the screen, and we're gonna take a look at this in just a moment. So an element is a pure substance that cannot be broken down by chemical means. Do you think I made a song for it?
Yeah.
What is an element? An element is a pure substance that cannot be broken down by chemical means. You can do the signs for it. Do you want to try it? What is an element? An element is a pure substance that cannot be broken down by chemical means. You got it? So it's an element is when you cannot break something down any further. Are you made of a lot of different things? Yeah, when you study anatomy, you're going to find out you're made of eyes and a brain and your kidneys and your intestines and your knee bones and your femur and your toes and your tongue and your teeth. Lots of things make up you. An atom is as small as it gets, okay? And based on the number of protons and electrons, we can tell what it does. Throughout the ages, as they found different characteristics and discovered certain elements, scientists tried grappling with, how do we make sense of all this? We found hydrogen. It has 1 proton, 1 electron, no neutrons. Then we find oxygen. It has 8 protons, 8 electrons. We find lead. We find aluminum. These common things. But they hadn't yet discovered every element yet, right? So scientists kind of grappled with, how do we make sense of it all? And in 1867, a guy named Mendeleev started proposing. He was obsessed with it. I'll share a YouTube video about him with you guys. I don't necessarily recommend all of that YouTube series, but I think it's very insightful to show what made Mendeleev's periodic table of elements stand out from all the other men who tried to devise ways of organizing the elements. And Holly and I like the show called Victoria. Do you like Victoria? It's about Queen Victoria, and her husband, Prince Albert, was a member of the Royal Academy of the Sciences. And in the mid-1800s, a lot of science, it was the age of industry, people were discovering things. Lord Byron's daughter, Ada, I believe was her name, came up with, helped devise the first calculator. They were making so much progress. And, but scientists don't always agree because they don't all have the same information or the same interpretations or the same theories. But Mendeleev came up with this system of organizing them. There are horizontal rows and vertical columns. Starting from the left side, these are the alkaline metals. Everything is grouped into metals and non-metals. Starting over here with the most alkaline metals, and the most alkaline are the most reactive. When they encounter other atoms or molecules, they have strong reactions with them. As we go further, they're less reactive, and over here we have what's called the noble gases. Can you say noble gases?
Noble gas.
Noble, right? do not react with other atoms or molecules. So over here we have helium, neon, argon, krypton, xenon, and radon. Okay? There's a lot to learn here. Every one of them, we actually have this one. I'm going to send a link for your parents if you want to look this up, and I will also send a link to Theodore Gray's book, The Elements, and it tells you how different elements have common uses. Have you ever heard of neon? Not neon Kentucky. Some of you might have heard of neon Kentucky, but like a neon sign that glows at night?
Yeah.
Neon. What do you know, right? What about, let's see, chlorine. Have you heard of chlorine anywhere?
Yeah, in a pool.
Yeah, in a pool. What about nitrogen and oxygen? Did we learn about them last year? Yeah. They're in the air we breathe, right? Helium. Have you ever heard of helium? In what that floats up at your birthday? Helium. What's helium in? What do we get at your birthday? That floats on a string. A helium balloon, you silly goose. So you guys can look through that book and see if you recognize some of the things. I'm going to show you some things on here, and let's pull up our periodic table of elements. Notice each of them has numbers around it. There's a letter for it. There's the name of the element. So this is hydrogen, and it has the letter H. Over here is helium. It has the letters He. That kind of makes sense. Hydrogen starts with H. Helium starts with He. We have lithium, beryllium. The letters kind of line up with their English names. Don't be fooled though. Not all of them do. Sodium, you think of salt. Na. That's from its Latin name. There are several that come from their Latin names, like gold, I believe is, let me see, gold is, I think, not He. What is gold? Gold is silver is Ag. Copper is Cu. So some of them get their abbreviations from other things. I'm going to send you guys a link to, you can do this fun little crossword puzzle to learn some of the names of the elements. They put the symbol down here and you have to write them out. Also, there's a cool craft that I'm going to include on the website where you can make like cards using just the abbreviations, like write a thank you card using, TH and A and N and K, and write thank you using different parts of the elements. Isn't that funny? But, okay, so we have the name, we have the abbreviation. We have the number of protons, and then we have, it's atomic number, and then its atomic mass. The mass is essentially its weight. Most of its weight is in the nucleus with the protons and neutrons. The electrons barely weigh anything. So in hydrogen, for example, it has 1 proton, which means it also has 1 electron. Its mass is 1.0079. So to find out the number of neutrons, we subtract 1. So 1.0079 minus 1, essentially 1 minus 1. We find out it has 0 neutrons. The heaviest naturally occurring element is uranium, which is 92. Notice that they skip down here. These are the most reactive. These are called let's see, what are they called? Lanthanides. They're very reactive. But uranium has 92 and it has, let me see, atomic weight of 238. So that means it has about 149 neutrons. Okay, see how this little bit of information, and you can gather so much information about each atom. Kind of cool. So we have our alkali metals. Alkali are really reactive. We have our alkaline earth metals. Then we have our transition metals that are not very reactive, but are good conductors, and they're malleable, meaning you can move them. Then metals and metalloids are halogens that are really reactive, and then our noble gases. That's a lot of big language. But you guys, it doesn't have to be overwhelming. Just play around with it, familiarize yourself, maybe play a game. I'll send your parents some links. The big thing in 3rd through 5th grade and younger is just to get familiar with it. Let's look at some of the stuff that you might have around the house. You can also do your own scavenger hunt with your parents. So let's look. Have your parents ever taken these? These are Tums. Do you know what Tums is? Calcium carbonate. Do you hear any words on there that might be elements?
It helps with your tummy.
Yeah, look. Let's find calcium. There, number 20 is calcium. And carbon is number 6. Calcium carbonate. Do you know what else is calcium carbonate? Typically chalk. Or anything made with limestone. Or something from the beach. Shells, right? Calcium carbonate can come in different forms and uses. Your classroom chalk is actually usually gypsum, not calcium carbonate. They're tricky. Real chalk is made out of calcium carbonate. Let's see what else we have. Ooh, for when you get hurt. This is called iodine. Iodine. Can you find iodine on here? Let's see. There's iodine, number 53. Iodine. Hydrogen peroxide. We have a lot of stuff in our first aid cabinet, huh? Hydrogen. Have you ever heard the word hydrogen?
Yeah.
Yeah, number 1. How about oxide? What does that sound kind of like? Oxygen, right? Hydrogen peroxide. Let's see what else we have. Ooh, bactine. Benzalkonium chloride and lidocaine hydrochloride. What does chlorides kind of sound like? Chlorine, right? So that's number 17. Some of these things are not exactly like the name benzalkonium may not be on the elements, but it may be a combination. Since you can combine multiples of the same ones, or you can combine multiples to make either an alloy. You can make molecules and mixtures by combining different things. We're going to learn more about those later on. What is salt? Sodium, right? If you find table salt, you'll find a lot of times iodized salt, which is iodine, number 53, and sodium, which is number 11. What is this? Baking powder and baking soda. What is baking soda? Sodium bicarbonate. So sodium is number 11, and bicarbonate. Look, carbon. Bi just means 2, right? And this has bicarbonate of soda as well. Sodium aluminum sulfate. That has a bunch of words. Sodium, let's find sodium, number 11. Aluminum is number 13. And sulfate is sulfur, number 16. What else has aluminum? Aluminum foil, right? Or, sometimes you have, you can have aluminum casings for on bullets. They also have brass, which is made of copper and zinc, or lead. Let's see what else we have. We have silver. You know what? Does this look a lot like this? Right? They both look kind of silver. And wait, my rings look kind of silver. But look, this one is gold. Let's find gold. Gold is where? Where is gold on here? I can't ever remember where exactly gold is. Can you help me? Yeah, tin sometimes looks like this, which is number 50. Gold is AU, which is number 79. Platinum is number 78. That also, you can have platinum jewelry. My wedding band is actually platinum. And a lot of times your silverware, even though it looks silver, is not silver like the element, but it's chromium, which is number 24. Isn't that kind of cool? Ooh, you know what else? We have been working on building our deck. And a lot of times deck nails are hardened steel. But you know what you do when you're building your deck? You don't use steel. This looks just like a steel nail, right? But really, sorry, it's very bent. We had to pull a bunch of them. Really, this one is actually labeled, is steel, but it's covered with zinc. Can you find zinc on there? ZN. What number is it? Number 30. Zinc keeps it from oxidizing and rusting. You don't want your deck to be rusting, right? Let's see what else we have. We have phosphorus on the tips of your matches. That's what makes them catch fire. Phosphorus. Can you find phosphorus on there, babe?
You should never use a match
without a parent.
Without a parent.
Do you think we've had this conversation?
I grabbed a match.
Yeah.
I scraped the match and I got fired, not on my finger, but on the match.
And then you lit a candle
and
first?
I lit a candle and I blew it out.
And then you always put it in water afterwards, right? So you don't start a fire. Fire safety, right?
Yeah.
So phosphorus is number 15. Let's look around it. There's sulfur and silicon. Why do you think it's called Silicon Valley in California? Because all the computer companies are there. Ooh, let's look on this. Do you know, lots of cleaning supplies are labeled. There's ammonia. What is ammonia? Do you know? I don't know. Is it a molecule? Is it a combination? Well, we'll have to look that up. Last year we studied rocks. Do you remember how we studied rocks last year? And we talked about, what's funny is, you think of a penny as being copper, but really, because copper is pretty expensive, they make it with zinc. But the wires in your wall, these are usually copper, because copper is a good way of, conductor. But notice, certain rocks, all of them are made up of minerals, which are found on our periodic table. And we found that even though we can't see the difference, we could tell the difference between some of these by whether they react to magnets, right? That's what we did last year. And notice some of them do not react. And then look at this one. It does react because this has iron in it. Can you find iron? Let's see iron. Can you find iron on here? You find it? You keep looking. That's iodine.
No.
Keep looking. So you guys notice these are all around you. Do you think that you're made of elements?
Yeah.
Yeah, they're the building blocks of everything, right? Hold on. Let's just put the magnets away. It's all right. We'll leave them down there. Did you know your body is, let's see if we can find the elements you're made of. Maybe we can mark them off with your pencil or something. We have oxygen. You are 50% oxygen. Did you know that? About a quarter of your atoms, half of your weight is oxygen. Next is carbon, number 6. Then hydrogen, number 1. And nitrogen, number 7. Those are the 4 biggest things that make up your body. It's the same stuff that makes up our atmosphere, right? You also have calcium. Let's find calcium. Phosphorus, sulfur, potassium, sodium, chlorine, magnesium, iron, fluorine, zinc, strontium, iodine, copper, manganese, and molybdenum. Try saying that 20 times fast. That's what makes up you. You are made up of these things. The things all around you. You know, you take vitamins, right? Let's see if we can find any of my vitamins. Do you know what the difference is? You take vitamins and minerals. Both of them are needed for your body to be healthy. Vitamins are the things that are made by organisms, so plants and animals. Like when you go out in the sun, you don't absorb vitamin D from the sun. The sun triggers a chemical reaction in you to produce vitamin D. When you take vitamin A, that beta carotene, it's a matter of you eat beta carotene and your body produces vitamin A, and your body needs that to be healthy, right? On the other side, minerals are things that come from the earth, and we need minerals. We need to have iron, right? Here's my, let me see, we have my iron supplements, right? You don't need tons. You need iodine. My vitamins here have iodine. We have calcium, phosphorus, iodine, zinc, selenium, chromium. Wait, you're telling me I eat the same stuff that my fork's made of? Yeah, pretty cool. You guys, so why do we care? Why do we care what we're made up of and what our vitamins are? If you want to be, what do you want to be when you grow up?
I'd like to be a vet.
A veterinarian. Do you think you need to understand what the animals are made up of? And you need to understand, sorry, I need to get rid of this. Do you think you need to understand what things your animals need to have good nutrition? Yeah.
They
Do
need
you
shots.
think you need to, hold on. Do you think you need to understand if a dog comes in really sick and you find out that it might have been poisoned? If you understand the compounds that it might have been eating that made it sick, that can help you better serve them, right?
Yeah.
If you know that bones, if you need calcium and vitamin D to have strong bones, it's gonna be able to help you take care of them if you understand where you get calcium. What about beauty products? You have to understand the chemical composition. If you want to build stuff, if right now we're building a deck, if my husband just used regular steel nails, our deck would fall apart. But by understanding the properties of zinc, we can make a stronger deck, right? If you understand how the cement is made, the composition of the soil, all those things, I don't care what field you go into. If you want to be an astrophysicist and want to put people up in space, do you think you need to understand how these elements react to one another? Of course, you have to understand the properties. I don't care what job you go into, having an understanding of the things that make up this earth, it's not only going to glorify God by having a better understanding, but it's going to make you better at your job. Ooh, I found another thing that we didn't look at yet. Lithium batteries, right? Now, most batteries they're made of alkaline things. So zinc, manganese, potassium, and graphite. Do you know your lead pencil? The lead in your pencil is usually not lead. It's actually graphite, which is a form of carbon. My diamond in my ring is a form of carbon. Isn't that funny?
Yeah.
Can I use my diamond to write with?
Yeah.
No.
No.
You guys, also the people who made the first computers, they had such an understanding of how these things could react. We wouldn't have telephones today. We wouldn't have the internet today. We wouldn't have computer chips and cell phones smartphones, if we didn't understand how these things can conduct electrical signals. So amazing, you guys. Anyway, I will look forward to working through it with you this week more, but let's have, ooh, I forgot, I'm a little bit hungry. I think I could use, can you use some thiamine and niacin and folate and phosphorus and magnesium and zinc? Look, I've got some for you. Oh no, she almost bit my finger off. Yum. So good. I think I'm gonna have some water too. Some H2O. What do you think? Is that silly? Hydrogen and oxygen. Great stuff, right? Okay. So one last little game. You guys go explore around your house. I am posting on the website a ton of things you guys can do with your parents to help you just appreciate the periodic table. One thing, oh, I forgot my borax too. Borax is a common one. Boron, if you want to find boron on there. We have so many things that we could play with. Go around your house. See if you can play a matching game with the things on here. do some crafts just to familiarize yourself. We also bought this puzzle. We love puzzles. And it's just a good way to kind of familiarize yourself with this. You don't need to memorize it as a little kid. Please stop distracting on the video, babe. But it can give you some familiarity with it so that when you get to be older and you're studying chemistry and it moves at a super fast rate and you have to understand how all of these atoms and molecules and compounds work together, you'll have the foundation already in your brain so that you'll be able to ace all your chemistry class in high school. I also made a little puzzle for Holly here where we're gonna use the numbers like 29. You find number 29 on here and you write CU, okay? So let's write CU. And then number 52, can you find 52 on here? 52 is what? What letters? T-E. What's number 39?
39.
39 is Y. What's number 8?
8. 0.
Is O. What's 92?
92.
It's way down here, right? 92 is U. What's 90?
TH.
TH. Ooh, let's look. CUTEYOUTH. Cute youth. That's what you guys are. You're cute youth. Anyway, you're not only cute, but you're very bright. And I cannot wait to work with you guys. Go home and study your memory work for this week and from last week. What is chemistry? The study of matter and how it changes. What particles make up an atom? Protons, neutrons, electrons, right? What is an element? A pure substance that cannot be broken down by chemical means. And how many elements exist? 118. We changed our memory work from last time because it's really hard to understand the naturally occurring versus man-made. But just be familiar, there are 118 things that make up everything. They combine in different ways. They make up you, they make up me, they make up our mini-wheats, right? I hope you guys have a great afternoon and I will see you soon. Bye, you guys.
Bye, you guys.